Okay, we're going to talk today primarily about operator overloading, which is a really powerful feature in a lot of object-oriented languages, but it also unlocks a lot of mysteries about Python, C++, for things that we're already kind of using. So stuff like strings and vectors, container classes, and in general, how other people write and develop classes. We've probably been seeing these patterns all along. We didn't realize it. So operator overloading kind of unlocks a lot of that stuff for us, and we'll be seeing it throughout the rest of the semester. So this is kind of our deep dive into it, and then we'll just kind of start using it gradually in various ways, or we'll start recognizing where other people are using it once we understand what it's all about. Quick stuff. So don't forget your lab 3. It is an important warm up. So do try at least to make sure you understand that, because we're going to pick up speed on that stuff. And if your kind of basic pointer stuff is a little rusty, that can make things a little tougher. We're going to talk about and start our risk game collaboration. This is very experimental for me. I usually like to have things pretty locked down, but we kind of did, a little bit of a chaos thing last year. We did this class and everybody really enjoyed it. I felt sort of guilty. It was such a mess, but I think people came back and said, we like that. We want to do more of that. So we're going to try this. I can't promise you it won't be kind of messy around the edges. We're going to try to spread it out over the course of the semester. It's really going to end up being worth about 4 of your labs, but I'm going to try to figure out a way to reward people who continually participate by giving you a little bonus points on your midterm and your final exam. So if you're in the mix and you're doing your thing as you go throughout the semester, I'll try to throw out a little extra high-level credit for folks to just kind of reward you for showing up and participating. So, because we want our teams to not be teams of one, right? So we want people to collaborate. Today's it's just really just about figuring out who your team members are and then submitting a very, very lightweight skeleton class by Friday. So that part should be relatively easy. We'll talk about that when we get to the end of the class here. So that's kind of our 2 big things. We have homework 1, which is still, of course, just our bouncing ball. So hopefully everybody's given that a little bit of a thought, and your quiz coming up. That is really just a review and does not cover today's lecture. So you don't have to worry about today's lecture on our quiz for Monday, or Tuesday. So don't let that worry you. It's really just about review of all of the basic stuff that you should have actually been exposed to in Comp 130 or an equivalent course. So in general, these are a little bit easier points than what's going to come ahead. So don't lose the opportunity to score yourself some points here, especially on homework 1, because things do get a little tougher as the semester goes along. Okay. So today we're going to be talking about just reviewing some things on prototypes and more on classes in the form of object overloading. Or operator overloading. The idea here is if I had some ingredient class and I wanted to simulate the idea of addition and subtraction and multiplication, how can I incorporate that into the C++ language when it doesn't even really know what my class is or how to add 2 things together? So fortunately, obviously, as programmers, we can enhance the meaning of plus in the way other programmers have for their classes and have that come up with something brand new. And it just depends on what we want to define plus as being. And that really is what we call operator overloading. It's just another form of method overloading or function overloading or constructor overloading, but it actually applies to any of a number of different symbols. And that's pretty cool stuff. That means we can just redefine what all of these things mean. So maybe we're talking about Pokemons or, putting together, different elements in an alchemy game or adding 2 or 3-dimensional vectors together or matrices or you name it. So once you realize we have this potential, you kind of go, oh yeah, like I could imagine solving some really interesting problems in a lot more compact code. And that's really what this is all about. So, this is not entirely right. We're going to talk and work on our lab 4 today. It's really just a starter. So it's not a very comprehensive lab. So that one's a little bit out of date. But this is really majorly what we're going to be doing today. And so we'll explore that in the time that we have. You just don't have to worry about it being on your quiz 1 for Tuesday. Okay, so a couple key points from last time. Remember, our prototypes So I've been teaching everybody, put your prototypes at the top, code at the bottom for a reason, because starting next week, we're going to start separating out our code into multiple different files. And as we'll see with our collaborative development, starting with Lab 4, we all need these files to work together in concert. But that can be a pretty messy proposition when we're doing this in C++. So, you know, starting out and being familiar with our prototypes and knowing the difference between that and the actual implementation is key, okay? And of course, we said we can overload stuff, which is really great, and we'll see that for sure with our operator overloading today, okay? We talked about constructors. We introduced this pointer. Remember, it is a pointer, and so we follow it with an arrow all the time. And we said that we have defaults in our arguments for our functions. So all of those things we'll just start using like crazy. And we'll actually be passing instances of classes directly into arguments, especially today. We'll see a lot of that going on, okay? So hopefully this stuff has gelled for you a little bit. If not, make sure you go back and make sure you do your quiz 1 at least one time. I think it will help reinforce a lot of that stuff, okay? So I think we saw that. So today, reviewing prototypes, again, really it's just no guts, right? You have everything about your function. And even if this is a method inside of a class, we will start to describe methods just by describing their prototypes, right? So this could be a method with a semicolon, no curly braces, or sometimes I say no guts. We still think of that as a prototype, even if it's describing a method inside of a class. So where we're going to go in the next couple of weeks is pulling out or separating out our classes, so you have a prototype for a class, and then separately all the guts are going to be described about how that prototype actually works in real life. So that's going to be a really, really key difference we'll kind of see coming up. But it'll more or less follow this pattern with a few minor changes. Okay. So let's just do this real quick as a warm up, right? So what we want to do is kind of go in and just run this thing, right? So take a look and see what happens if we run this, so you're familiar, because I guarantee you're going to see these kind of errors. Now, depending on the system that you're in, you might see a different kind of error message. But the key thing here is realizing that there's some undefined reference. It's not like a compiler bug. It's just like a, oh yeah, I forgot to write that kind of bug. So compiler comes in and says, oh, okay, you got these things. I see what they do. I trust you. I trust you. I trust you. And it's fine all the way through here. And then if it's missing something down here, then it's the loader or the linker that is actually going to complain at you. Because the linker sort of looks around in the file system and says, okay, everything compiled just fine, but I can't find a definition for this thing right here. So it's not really a compiler bug so much as it's the linker kind of looking for another piece of the puzzle that it assumes somebody built already. And when it can't find that, we get a different kind of bug. And notice there's no particular line number here. So those are really annoying. You just sort of go, I don't know what that is, right? We got to just be a little bit clever, undefined reference to malt, and kind of go, oh yeah, I was supposed to write that thing, right? So you got to come down here and pop that thing in. And you could just copy paste that thing and pop that down there. And of course, as we said all the time in my previous class with you guys, you got to match this thing, the signature, directly. You could change this to X and Y. Most people don't know that. You could call this X and Y down here, right? But the compiler is looking to match the types. So it's getting the type or the function signature from this description, and whatever you call X and Y, A and B, it can be different. It's not a great strategy to follow, right? Usually I just copy paste the prototype and then finish implementing. So hopefully that all makes sense to you. And when this happens, when you compile your code, and I guarantee you it's going to happen when we put all of our classes together for RISC the first time, we'll probably have some mismatch types. So we'll have to just kind of work our way through that. Okay. So that's kind of our first thing. And we definitely don't want to throw away those prototypes, right? Those are the blueprints. So please don't kind of replace them with your code. We just want to keep those things around. Okay. So again, linker errors are really the last step. We never really see it. So let's say you're working on a team full of 40 people in C++ out in some real job, right? My job is to compile and test my class. You got to compile and test your class. Each one of these classes essentially produces a .o file. So a .o file is a compiled bunch of zeros and ones. So far, most of us have really only created main.o, right? Everything's been in the main.cpp, so that created a main.o. But we're moving into a realm where we want to be able to work in large teams, and that means we have different files. And maybe I compiled my file this morning, but you came back and changed yours. So there's no reason that my .o needs to be recompiled. It just needs to be linked back in again. So that's what the linker is doing. It's looking for the zeros and ones that are already cooked and ready to go in maybe dozens or thousands of files, and then only recompiling the things that need to be recompiled, maybe because they got recently changed. And then it glues all those pieces together. We call that the linking process. So the last thing we're trying to do is sort of put everything together in one file, and that becomes our executable. So the initial stage, and we'll get more into this, of creating all these separate .o or separate object files kind of happens first, and then they all get munged together. And that's the part where the linker kind of goes, hey, I seem to be missing something. Somebody forgot to write that function wherever it is. Not a problem usually if it's all in one main.cpp file, but it can get very, very confusing once these projects get a little bit bigger. Now, although I know we've kind of moved away from Replit, some of you who are still in it kind of have the advantage of what you'll see on the next slide here. So this is just the solution to our problem, right? We want to actually finish implementing all of our prototypes down below, which is perfectly fine. And you'll notice, of course, they're not inside of main. Really easy to accidentally slide them in above that curly brace, but please don't do that. Now, if we could see our file system, and some of us can, right, in VS Code or in Replit, Program IZ, not so much, but there is a main file that's created. That's main executable. So we're not really seeing the exe, and it's not even strictly required. But there's our main.cpp, and there's what got produced by our compiler. Now, if we had a whole bunch of CPP files, like for our risk game, we're going to have a .o for every one of those separate files. And then finally, those things would be glued together into some final executable that we can push right down onto the executable hardware of our particular machine. Okay, so that's our executable. That's our program, right? Main.cpp is really just a dumb text file, right? That gets crunched together into the .os, okay? So that's really our goal. And if we were able to get access to an operating system, so this is a Linux operating system, if you're ever kind of mucking around with a Replit, right? And of course, we have Windows operating systems in here. I'm more of a Linux person myself, but if I could list the things in a particular folder, I would see all the files, right? And so I see my executable and I see my text file. And if I want to run that executable in Linux anyway, I just say /main, and that's me telling the operating system, here's my zeros and ones, go crazy, right? And so that's really what's been happening all along. Most of you probably realize that, but not all of us kind of are down at that operating system level. So it's good to be aware that it's not quite as magical maybe as Program IZ or Replit actually makes it look. And so our goal is to create that thing, and maybe out of tens or hundreds of these things, right? And there's something we'll see a little bit of called a makefile that sometimes guides that construction process. It tells us how to find and put together those things. We're not going to really get into that too much in this class. But again, it's really nice to know that those things are there. And at some point, you'll probably learn a little bit more about that stuff. So that's the background. We'll see more of that when we kind of dive in and start expanding on our risk stuff and our other multi-file kind of development projects like Facebook. We're going to do a Facebook thing. We're going to do a chess thing. So we'll come back to those a couple times over the course. So let's talk about operator overloading, which is our main topic for today. So it's really just like method overloading. At the end of the day, once we train our eyes to kind of see a little differently, we'll sort of recognize, oh yeah, I'm just kind of adding a method to my class that overloads some behavior. Okay. The idea, though, is that we're overloading a symbol rather than overloading some other existing method. We're saying, hey, I want to change what a plus means. Okay. So plus, minus, times, all of these symbols are kind of like locked in. Like, and if you can look at your keyboard and find a curly brace or a square bracket or a comma, so many, if not maybe all of those things could actually, we could change their meaning in code. So we can make them mean slightly something different. Okay. But we can only do that in the context of a class that we are developing. Okay. So we know we can say 1 plus 1 and we'll get 2. That's a very fundamental operation that C++ understands. But if I have an animal class where one variable is called dog and one variable is called cat, what does it mean to add two instances together? So if those variables represent instances, not types, but instances, what does it mean to add? Well, C++ doesn't know. We have to inform C++ by the definition of our animal class. So that's kind of the fun part, right? So let's change, examples here. I used to love playing this game ages ago, but I have 3 instances of an ingredient class. Okay, so this is my ingredient class. I've called my variables air, fire, water, and let's just assume that they just have one data member. That's a string that says what they are, right? So, but how can we do this? Like air plus water would be cool if C++ could look at inside of the ingredient class and know, oh, if you add air and water, I'm going to actually produce fire, right? So that plus symbol there is what we want to overload. Like, it'd be great if it just, the class knew how to build up all these compounds. That would be kind of a fun thing to code up inside of C++. So we want to have something like this, right? Where we create an instance of air and we give it air. So it's by virtue of its constructor, it's intended to be an air instance. This is just the variable name. We could have called that ingredient 1 of type ingredient if we wanted to. And there's water, right? So I want to be able to teach my class how to do these kind of cool tricks. So there's my ingredient class. I've got a name, private name, or in this case, public, right? So I'm going to initialize that with whatever somebody tells me. And that's my basic ingredient, okay? And so we're going to work today to build up a class, not the ingredient class in this case. We'll come back to that in a second, but we're going to build up all of these different operators in here. So here is A calling the default constructor, right? So it's going to be unknown by virtue of the fact that I didn't put any parentheses on there, and that's perfectly fine. So that's what that is going to be. And of course, that's going to be salt, okay? So if we want to add two ingredients, we saw last time in lecture 322 that we could have an add method and pass in an instance of one ingredient. And then the add method belongs to the air instance, right? So it's like, hey, I'm going to add you and return something new, an entirely new copy of that particular class, right? It's not a pointer to a mystery thing. It's actually the actual instance, okay? So that's really kind of the logic behind what we want to do. And then, of course, we could print out what that thing is and find out, hey, what did the add method actually create for me, okay? And in theory, we should be able to add water dot add air, right, and get the same thing, right? So the add method should be able to figure out what we produce regardless of the order of who's adding to who, right? And what we're returning there, okay? But it'd be cool to go like this, right? So now we can sort of dispense with the Cody kind of part of that and start thinking about these things at a higher level, kind of like the way we think about math, right? So just add them, right? Figure that out, right? But it's still, the idea is that this is being added to this, right? So it's almost like we want that, add to be sort of interpreted, through that plus sign there, okay? So let's take a look at how we actually just first off build that add method. Just as a review, we saw this last time, but we're passing in an entire ingredient. And so there are probably better ways to do this add, but just to keep it simple, we're just going to say, hey, if I am air and you are water, then I know that I want to create a new ingredient that is comprised of fog. Okay. So in theory, this could be a really big kind of if-else combination of things that produces all of these cool other ingredients, and they in turn could produce other ingredients, whatever. So we could build a pretty cool game with that, right? So, but that's going to work. And the key thing to realize here, and I know we talked about this last time, is that we are creating a ingredient, a very transient ingredient by calling the constructor directly. Notice I'm using the name of the class, which is green, right? This is my constructor. I'm saying create an instance and then return that thing. And you can see that the add returns an instance. It's not a pointer to something. So we get a copy, and then this thing goes away, but the copy survives, right? That's what goes back to the calling instance. So down here, when I say air.add water, I'm going to create the fog, and then I'm going to make a copy of it, and that copy gets copied into the mystery, right? This mystery ingredient over here, and then this thing just goes away, right? Because that's inside of the scope of our add method, okay? So these are just the base level mechanics of what's going on. We kind of talked about some of that stuff last time, but just want to make sure we're all clear on that, right? And so if we kind of ask ourselves, what is the return type? We should be able to find that out in two ways, right? It's the type of the method, okay? And it should very much match what we're actually actively creating down here, okay? That's a transient constructed instance of the ingredient class constructed with the fog, okay? So that is kind of what we want to do. Now, I changed something here. So the only difference that we have to add in order to support that plus is just this very simple change here. So we changed add to this reserved name called operator plus. And now we get to actually add those things together in a mathematical way in main, okay? So, but just to show you that it actually is just another operator, right? We could say air dot operator plus water. So rather than calling it add, we just sort of changed the name to this weird name called operator plus. But the fun stuff is that we can just go with plus, right? And so now we are all set to go. But what we're really doing there is we're passing in water as the second operand of the plus, and it goes into the operator plus method in that way, okay? So operator overloading is just about learning the secret names of all of the symbols and then thinking about how to do them in a way that kind of matches this left-right scenario. Air here is on the left or left-hand side. And so really it's the one that's owning the operation, if you will. So we really are doing that when we say air plus water, okay? And that's really all it is, right? So if it makes sense to use plus between two instances, right? Those are just two instances. We get to decide actually how that's going to work, okay? Questions on that part so far?
Would you have to make one specifically for water plus air?
You would. Yes, you would. Yeah, you could do it like if this equals air and that, or, the other way around. So you can make a compound, It's not a pretty way to do things in the large scales. There's some other strategies we'd probably follow. But we'll see for things that are maybe a little bit more mathematical, that it's a little more straightforward. So the cool thing is that an amazing number of things can actually be overloaded. And you may be very surprised for those of you who feel very comfortable with vectors and you're like, yeah, vectors support square brackets. It's awesome. Actually, they don't. They actually do via overloaded operators. So the good people who wrote the vector class kind of faked us out, and they said, oh, we'll pretend we support square brackets, but really it's an overloaded operator inside of the class. And so what's really awesome about this idea is we can kind of help other programmers by designing classes that act in really natural ways for symbols that they're really comfortable with. Like, what does it mean to compare, air? Is air great? I'm sorry, is air greater than or equal to water, right? Maybe that relates to its molecular weight. I don't know, right? But we can actually create an overloaded meaning for that so that people can just talk about code at a much higher level and not worry about all this dot calling stuff, right? And that's the really cool thing about this. And we're going to see this over and over and over throughout a lot of the classes that we work with this semester, is that it's all around us. We've been using it all along. We just might not realize that's what's going on. Okay. So vector uses it, string uses it, and we'll get deep into all the container classes and kind of see how they work. But let's just see an example of this, right? So here's Mickey and Mouse, right? So again, this is kind of syntactic sugar. We're just saying, hey, do this, right? Make it look nice, right? But there's my two instances, and I could say first plus last, right? And that works just fine, right? Or I could say first dot operator plus last. Feel free to try that, right? So you can actually call operator plus directly if you want on some of these, classes that already exist, okay? And I didn't know we could do that, right? In the beginning, I was like, okay, yeah, I knew I could do that. It's like, oh, wow, I can like reach in and just call that thing by name. That's kind of cool. It kind of helped me realize all these things are very connected, right? So that's the idea. And of course, all these other things are just methods in the class that these people wrote, okay? So really, string is masquerading kind of like a data type up here, right? So what it's trying to do is just make us think it's like int x. Question?
Yeah, this might be kind of ridiculous, but if we were to just put like a number, or just like an int, and we use the operator plus, and then put another like int in there, would that work without like?
Well, it's going to look for an overloaded operator plus. So you can have multiple operator pluses that take different types of arguments. So we'd have to write it, but we could. And we'll do that. Like we'll do some vector math at the end of this lecture where we'll be like, hey, what if I got a vector and I want to add 10 to both components or 8 components, right? So that exactly is totally possible. We just got to do a little bit more overloading to do that. So I know we already got an int type, but let's kind of develop this thing, and we're going to do this incrementally in class. So if you want to follow along actively, you'll kind of have to, well, you don't have to, but you may want to do little bits of coding at each one of these junctures. So kind of prepare yourself for that. It's just little bits every time, but it's kind of helpful to see this all come together. But this is kind of what we want to do mathematically. We're going to wrap an integer inside of a class and then slowly add the overload so we can just kind of do with it what we want mathematically, right? We want to say 1 + 2 = something, right? And put that in the sum, okay? So let's do that. So let's step back and just remind ourselves all of the things that we can do, right? So these are just the names that associate themselves with those symbols. We'll kind of start out with the slightly easier ones and slowly work our way up from there. But those are kind of pretty symmetric. So if you know how to do the plus, you kind of can do the minus and the divide and all that. Okay, so those are our method names, right? This is kind of the arguments that we pass in. And to Iago's question, we could overload the plus so that we pass in an instance or just a constant value or an integer value, right, rather than another instance. We could have 2 of those operator pluses if we want. Totally fine. And then there's our implementation there, okay? So we'd have to pack all this stuff in. And for the moment, just note that we're returning a copy of whatever it is we create in here. We take a little snapshot like we got a photo camera and we push that back through the pipe, okay? So even if it's a temporary variable in here, when I return that temporary variable, if it's an instance, it's going to make a copy of that and back it goes to whoever sort of called on that particular method, okay? So in the big question of like, do I get an instance or a pointer? If you're not seeing a star over here, of course, we're not returning a pointer to a number. We're just returning the number, okay? So most of us probably are pretty comfortable with that, but I'm just going to reinforce that as we go along, okay? So there's no star over there, okay, in the type. Okay, so let's kind of build this thing out. So let's just try this. It's always helpful to kind of, keep your skills up, right? So we want to create a number class with a public int variable. Now, your homework today or your lab today is just so simple, right? So all we're really trying to do is throw together a class real quick. And we should all be able to do that, right? So if I need a number class, all you got to do is just say class, even if you don't remember exactly how to start it. It's like class number, curly brace, semicolon, and you're off and running, right? And I got to spell it right? Number, okay. And it's going to be private by default. So we got to say public if we want it out there. And then we'll say int. I think we said number, and then we'll have our constructor. Number, it's going to take an int underscore num, I guess. You can call it whatever you want. I'll give it a default value if someone forgets to give me one. And then I'll just say number equals underscore num. Okay. And we're off and running. So that should work for us. Let's see if I've goofed anything up there. Ha, yes, I did. See at one of the instances. Oh, did I see out one? Prints out public value. No member val. Okay, sorry. Yes, sorry. I changed it to val, right? So my private or my public data member should be val, right? Sorry about that. There we go. Okay, and we got our base class off the ground, which is good, okay? I just need to follow my own directions there, okay? So now we want to continue this. And if you're like me, it's a little tedious in the beginning, but the cooler stuff, the more cool stuff you add to your class, the more fun it gets. So here's a good one. So let's say we want our class to be able to return a description of itself. So maybe that description is trivial, or maybe it's like a long sentence that says, I'm a red car with 4 doors and a hatchback, right? So getString is a good method to conceptualize, right? And a very helpful method that's part of the string library, if we're using strings already as a data type, right, is the to_string method, okay? So we're going to use this inside of our getString method to convert an integer into a piece of text, okay? Specifically into a string data type piece of text, which at first glance, it's like, well, doesn't that happen automatically? Well, it does in cout, but it doesn't happen automatically inside of our code. So we want to provide a method that actually does that so that we can say one.getString. And you'll see where I'm going with this, as the lecture, continues. But we want to add that method to our class, right? So I'll let you guys kind of run with this one, but it's going to look something like this. So feel free to add it. There's our constructor, right? Notice that I just sort of threw in this arrow from our last lecture, right? That makes it really clear. We're talking about that guy right there, but you could leave that off because we did the good thing of putting an underscore there, but it doesn't hurt to actually use that if you want to do that. So here's our getString, right? So we just convert the data type, which is integer, to a string, which matches the return value of our method. And that's going to come in real handy a little bit later on, okay? We'll show you how. Okay. So, and it's easy to confuse these two strings, but we are just returning the string, right? It's kind of different than print me. So I know in our beginning classes, it's real easy to mix these two up. Print me directly puts it out to the screen. GetString returns the string so somebody can do something with that string later on, right? So they're kind of related, but one is a cout and one is a return, okay? And now let's add our addition, right? So remember that the thing on the left-hand side is kind of this, and the thing on the right-hand side, I tend to call it RHS and LHS sometimes. That's the operand or the instance that we're passing in, okay? So RHS is on the right-hand side, that's the B. LHS is our A. So we're going to essentially be A dot operator plus B, okay? So we have to, when we're inside of the method, think of ourselves as the A, and the thing that we're receiving is the B, okay? So, and we saw this before, but just breaking it down for you one more time. That's the name of the method, okay? And sometimes, unfortunately, you're going to see a gap between those. People are going to write code where they'll say operators space plus. I hate that because it just sort of breaks the magic, right? That's really the name of our method. But yeah, you can put a space in there if you want. It's kind of weird, okay? And then there's what we're doing inside. So here I'm doing it a little differently than I did it last time. So you can follow this if you want, but it's a really good exercise. We're creating a temporary variable. It's called new num. It is of type number instance. And it's going to be the sum in the constructor. We're going to add together the sum of me, the A, with what just came through on the right-hand side, okay? So we're sort of putting our hand in the cookie jar, grabbing the val from this one, adding it to me, and that thing goes into the constructor of something new, and that's a local variable, okay? Think of that as a local variable. It's going to go away. But if I return it on the next line, then our little camera comes out. We take a snapshot and it goes out through the return pipe. And of course, that matches the data type so that we're passing back a copy, okay? So we, of course, haven't changed ourselves. We just returned a new thing, which is the sum of me plus what got passed into me, okay? So whether it's A plus B or B plus A, it really is the same result because addition, right, is associative. It doesn't really matter the order, okay? So that's sort of an elegant solution. And we could have done it all in one line. And I know this is confusing, but we could have said, you know, skip all of that and just say return number constructor with all of that stuff in there, like we saw in that sort of alchemy example. So both approaches are okay. You could argue, well, this is a little more wasteful, right? We could have just done it all in one line, but you know, it's a little more readable that way. Okay, so that's how we kind of break down our operator. Okay, and it's okay that that variable goes away. We're not passing back the address of something. It's like, hey, here you go, take a picture of this, you know, and then return that copy. Okay, and then the new number thing goes away. Okay. So I'll say this a few times this semester. C++ is a copy-centric language. It is always making copies of stuff. Like you pass in an integer, it's kind of a copy. You pass in an instance, by default, it's a copy. So more advanced developers find ways to minimize those copies. And we'll review how to do that, but no pressure on that right now, okay? So there's our method, okay? So if you want to add that, go ahead and do that, right? And now you should be able to do some cool math with your instances, okay? Which is kind of fun. And if you kind of want to see what the answer is, you can say cout sum.getString. And of course, you'll get back a string, and that doesn't even need to be converted by the cout, okay? But again, we'll come back to that getString and show you some cooler stuff with that, okay? And if you want, you can just reach in and grab, you know, your operator plus directly. Okay, so we're looking at something like this in our class. Okay, and kind of pack all that on one line if we want. And you can see here, I took the shorter approach. I just said here in this solution, I said just create a temporary copy, do the addition, feed it to the constructor, and then the whole thing goes back as a copy of a number. Okay, so that's our overload. Okay, and then in main, we can start doing our math. Okay. Okay, so you can call it directly or you can use the symbol here, right? Like so. Okay, questions on that? Okay, so if we can do plus, of course, we can do minus and everything else, right? So let's kind of move to, you know, something a little different, right? So a comparison operator, and this is hugely important for you algorithms folks, right? So if you are sorting instances of something like cars and you want to sort them by weight, how do we use like already written sorting algorithms? Because they don't know what a car is, right? Well, we overload the comparison operators. So cool. all we have to do is trick those already written sorting algorithms into using our overloaded greater than sign. And now they're sorting our instances of cars by weight or whatever we want them to be sorted by, right? So let's take a look at how we do that, right? So of course, operator greater, okay, and we got that sort of me and you kind of thing, left and right hand side. So what do we want to use to decide which one's greater? Well, we only really have one value, but if I had a car, it could be sorted by numbers of doors, weight, whatever, right? Or popularity or price. So it really depends on how we overload that thing. So here we just got value. So I'm going to say, well, if this value, that's me, the A value, is greater than U value, store the Boolean answer to that question here temporarily, and then return that thing, right? Which is really a copy, but it's a copy of a Boolean, so that just sort of happens every day, right? So now we return a copy of that Boolean, and is GT goes away, like it always does at the end of our scope. And now we have our comparison, which is so cool, right? So let's see if we can add that, okay? Because what we want to do now is just say, if 1 is greater than 2, do something, right? Or what's even cooler is if you remember our ternary operator, we can start to do things like this. You know, see out 1 is or is not. Okay, well, if 1 is greater than 2, overload, send this back into the string. Otherwise, send this back. And now we're writing really cool code very concisely here without having to call these methods and stuff, right? And our brains are, in theory, you know, not as taxed worrying about all of the low down guts, right? Because we've kind of elevated our coding a level there, okay? So we're really talking about this right there, right? So this is the shortcut, right? Return the answer to the comparison of this greater than that, okay? So if we said, hey, quicksort library algorithm, I want you to quicksort my number instances, we just need to give it an array of those instances, right? And it will compare them with a greater than symbol, and that will automatically, under the hood, call our operator greater than, even though the quicksort thing was written 20 years ago, right? And now it works with our brand new instance. And that's cool. That's really cool. And if we want to change the sorting order, you know, we could come in here and like change that to a less than, right? And we trick the sorting algorithm into sorting in ascending versus descending or something, right? So, but that's really a big deal. And we'll come back to that later on in the semester where we talk about functors and instanced functions, which is a kind of a popular thing. But that's what's just so cool about these overloads, okay? So now I can do basic things like that. Okay. And again, the meaning like depends on your implementation. We care about val, but maybe it's a car and it's got lots of attributes. So we get to choose which one based on how we implement that particular overload. Okay. Okay. All right. So let's talk about plus equals. This one's a little trickier, but not too much. So we kind of know if we have x plus equals 1 or x plus equals 2, that's going to add that to the a, and we're done, right? So how does that sort of manifest itself inside of our class? So it's a binary operator. So we have a left-hand side and a right-hand side. And so you can kind of see what the method is going to look like. It's going to be operator plus equal b, okay? But we want to be able to change a with this. We're not returning anything. So in theory, our return value here could be null, right? Or void rather, right? Because a should get changed by virtue of its own method, okay? So, but sometimes people will connect together many plus equals symbols in a row, which I've never seen, honestly. So, you know, I'll show you 2 ways to write this particular method. One of them is a little more complicated than the other. So here is our class, right? There's our operator plus. So we're really just saying, hey, I am changing me to add my number, that number to myself, right? So we're incrementing this guy up here, of course. And in addition, this could be a void right here, right? But if I want to kind of chain together many plus equals things in one long equation, which frankly, I think is very crazy and dangerous, but I would need to have something be returned so that it can be passed up the chain, right? And we haven't seen an example of that here yet. I think we'll have one on the screen here in a minute. But that's the only reason this thing isn't a void method. It's so that we're enabling someone to use that return value if they want to. So we're overloading plus equals. Our right-hand side is an instance, right? We're going to increment ourselves, and we're going to take a snapshot of ourselves, which is kind of crazy. It's like I'm dereferencing the pointer to myself. That's like taking a picture of yourself with a camera and sending it up the return pipe, okay? But the problem is, by default, it's an actual copy. It's not really me. I've made a copy of myself, which is a very tricky, subtle little thing, right? So if I want to return a reference, right, by default, you can kind of see here, sorry for all this kind of stuff in the way here. By default, it's a copy, right? And so this works just fine. And nobody really receives the copy back from A. It just sort of falls on the floor and goes nowhere. But if I want to do this, A plus equals B plus equals C, this thing needs to pass something back to this thing, okay? That's kind of crazy. I would never do that. But in order to do that, we put a reference there, okay? And this is tricky. Don't worry about it too much. But what it's really saying is the thing that we're returning is no longer a copy. It's the actual me. It's like, hey, I changed myself here. Now I'm giving you a reference to me so that you can move on and maybe do something with that further up the chain, okay? Pretty advanced stuff. So, don't worry about it too much. You could write this and be perfectly fine if you only ever expected your class to sort of be used like that. Oops, like that, right? You'd be just fine like that. Okay, nobody would really know or care. In fact, you could even make this a void right here if you wanted to, if you only ever really wanted to support that. Okay. So this part here is a little tricky. Don't worry too much about it. Just wanted to kind of introduce that to you. So you'll see that in code probably to cover all of your bases. Number, ampersand, return, and we return a copy of ourselves, okay? And that's about as advanced as we get with that kind of stuff. Like it gets a little bit squirrely for that particular example. The rest of them are not too bad, okay? So there's our, which one is this? Simplified. Oh yeah, so here's the simpler version, right? If you just want to do a simpler version, you just do this and you don't return anything, right? And that's really not going to support this model correctly, right? Sorry, this model over here, right? It's going to just be the simpler version, okay? So those two are very, very closely related, okay? Okay. So you can add that in if you like, and you should then be able to increment an instance almost as if it's an individual number, okay? So we're looking at something like this, and in main, we should be able to say 1 plus equals 2. And then when we print it out, we should see that the 1 has actually changed, okay? And remember, this was already a pointer, so we're just saying, hey, give me a picture of whatever that is. That's the dereference operator, okay? So go to the pointer, grab the instance, and send that back up the pipe, okay? Okay, all right. So now we'll just sort of, throw this out there. We can do multiplication, we can do division. All of those things are pretty straightforward. And again, sometimes you'll see people throw a gap in there. I don't know why they supported that. It seems like it's just asking for trouble, but you can leave a gap in there if you like. So some people actually do that, okay? So I'll leave that for you guys to kind of look into, right? But notice what we can do. So this is the cool takeaway here. So now here we are back in main, and we've got all of our kind of math stuff done. So I create a transient instance of the number 10. I multiply it times a transient instance of the number 5, right? So I'm calling the constructor directly. And then I put parentheses around that, and that calls my overload for math, which creates another instance, which has the final number, 5 times 10. And then that instance, I can call its dot get string method and produce the number 50 out the door, okay? So like I always say, we work from the inside out. C++ figures out this, then it goes, oh, you got an overload? Yeah, okay, cool, great. Okay, create an instance. Okay, now what's that? Oh yeah, that's just the get string of that new thing we just got back from your overloaded multiplication. Okay? So that's pretty cool, right? You know, obviously we could just do this with integers, but if this was something else like a vector or a matrix, that's pretty cool stuff, okay? We just got to break it down piece by piece when we read it, okay? Questions on that one? Okay, cool, cruising right along, okay. So there's our solution, right, for the division and the multiplication. Super easy once you kind of know the pattern, okay? There's our main thing, okay? Okay, all right, so let's talk about this one. This will play into one of our future homework assignments because it's kind of like some magic that we just sort of forget works every day, right? So if we do not overload the equal sign, what happens when we do something like this? 2 = 1. Compiler is okay with that. So, and yet we have not overloaded the equal sign in our class. So why does that work and what is it doing really? Well, it turns out that C++, if you don't overload the equal sign, will do what we call a shallow copy. So a shallow copy is what you might guess it is. That for attribute to attribute between same classes, it's just going to copy them over for you one by one. So if I got one attribute, it'll copy over. If I got 2, if I got 3, doesn't matter. It's just going to copy them over there. And now these two, they're not the same thing. So if this was Python, this would be a very different thing, right? So in C++, it's copying the values over. It's writing over the attributes of 2 with the attributes of 1. And that is very C++ specific, that particular behavior. So it's really something like this, right? We're just kind of pulling those things over. Okay? So imagine if rather than this being a value, it was pointing to an instance of a tire on a car, right? Let's say this is a car and this is a car, right? So if I were to copy over the values, guess what? Now this is pointing to the same tire over here. And that is a bad thing in a lot of situations. So that is why we call that a shallow copy, because it's not thinking very deep, right? It just copies over whatever the pointer was here to the pointer here, assuming that's a pointer, right? And now we've got 2 data structures that are linked together and you might not even know it, okay? And we'll see down the road here that leads to some potentially nasty problems. That leads to some very real world crash bugs for sure. We'll kind of see some of that, okay? Now we can go back and fix that problem, and we will, not right now, but we could overload the equal and then go, uh-oh, yeah, this is a pointer. I better not actually just copy it over. Maybe I better actually make a copy of what it's pointing to, right? And then I'll give you that new pointer, right? So that would be what we call a deep copy. So that requires that we overload this thing and do a little more work. But by default, we will get the shallow copy in C++, which most of the time kind of works for the really basic stuff. But knowing where its limits are is kind of key to avoiding some nasty bugs, okay? So that's really nice. So just one more look at the code for what we're talking about, right? So we don't even really think about it. It's like, oh yeah, of course I'll just make the 2 equivalent to the 1, right? And again, in Python, that would be a different thing altogether, right? Made me crazy when I first started coding in Python. I'm like, what are you doing, right? Python, they're pointing to the same thing. C++, you get a copy. It's like crazy. So you just got to know the difference between the languages. Okay. Okay. So that is our equal. So let's kind of move to something that's a little more interesting. We won't go too deep on this because I know not everybody likes this kind of stuff, but this is where I got really excited about object-oriented coding and, you know, doing graphics and stuff like that, right? So just some quick basics. We won't go too deep, but we'd like to talk about vectors. So vectors are composed of, you know, something along the x-axis and something along the y. So vector A is a 7 and a 0, and vector B is a 0 and a 12. Kind of think about it emanating from the origin, right? So if we want to add these things together, A plus B, right? Well, that would be in vector math, just sort of adding the A to the B or the B to the A, right? They're both going to take us to that point right there. So it'd be cool to just be able to write code that way, right? And so you can kind of probably guess where we're going to go with that, right? And if any of you taking physics, you know, this is what I was doing. It was like, okay, how do I do physics without having to do a lot of thinking, right? So write some classes and implement some overloaded operators, right? So there's my C equals A plus B, right? So we want to actually do that. And let's just look at the code, right? Because it's a little messy, but it makes everything pretty nice. So I conceptualize a 2D vector. If you can do 2D, you can do 3D and 4D and all of that. And then I will initialize it with its two constructor arguments, right? So there's my 2D vector off and running. There's my get string, and this is very handy. We'll see why, right? So now I've actually got this really nice little method here that's going to produce a very nicely formatted thing that's printable, right? So whenever I want to debug my code, I can just sort of print out or get string on my vector and see kind of what that thing looks like, right? Which is otherwise tedious to do. So I create it, I print it, right? Create another one, print that one, but we want to be able to, of course, add these things together, okay? So let's talk about this real quick and you can jump in if you want. So if you want to add an overloaded method for the plus, you can probably guess what you need to do. You're going to need to construct a new vector and return that as a result of the operator plus method, okay? And then we could increment something rather than returning a new vector if we want, okay? So if we were to do this, right, we should get 10, 10, right? If we kind of do that math should work, okay? So we could do all of our vector math, and this is what people do in computer graphics and self-driving cars, I guarantee you, and rocket ships and all of that, right? We just develop a class, base classes that support all of the important operations for vectors, and then we do matrices, and now we have this incredible math basis for doing things. And for those of you who know about MATLAB or you're contemplating taking that class, I guarantee you that's probably what their code looks like. If we could crack open MATLAB and look at it, they would have really cool sets of stuff in C++ that overload these operators. So let's look at how this thing comes together. So there's our constructor, there's our get string, there's our addition, just reviewing. Vector 2D has two arguments, this argument and this one, in its constructor. And that's what we have here. One argument, two arguments, okay? This is my x, this is your x, this is my y, and this is your y. That, of course, produces a vector which goes back as a result of the plus, okay? So that now allows us to kind of use that stuff in main. And then if I just want to increment myself, right, I'll just add it to me. And then for good measure, in case I'm being used in a chained way, which is, of course, rare, I think, I can just add that little reference in there so everything kind of works properly. Okay. But you could also just sort of shortcut it and go with a void there, right? If you really didn't care about that extra special sauce, you could just skip that part and just update yourself, right? And that becomes a void, okay? Right? Now, to the earlier question, which is a great question. It's like, okay, well, we're adding two vectors together. What if I want to add a scalar value to a vector? So here's vector A. I just want to say A equals A plus 1. What is the compiler supposed to do? Well, the compiler looks at this and goes, okay, well, you're a 2D vector and you're an integer value. Do I have a flavor of the operator plus that matches that combination? So it's going to look at your class, and if it doesn't find that, your compile will fail in C++. But if you do have that overloaded, in addition to vector vector, you have vector scalar. Now you got yourself covered, right? So we'd have to add that overload. So let's just see if we can actually take a look at that. And you're welcome to, of course, do this. So, but I don't know, it just makes me feel so good when I can write code and not have to worry about that. It's like, oh, it's done. Like I can just focus on the math now, you know? So now this right here is an integer value. And so if you write a integer overload and you try to give it a floating point value, you're probably going to hit a wall. But C++ might try to convert that for you forcibly. I will admit that I don't have all of its rules memorized, so I usually got to just check it and see, okay? My guess is it will probably try to convert it because it's really just passing it in as a function value. And we've all passed a float into a function argument that's an integer and seen it get crunched, but not crash. So I believe this will actually work. We'll just kind of lose our real part on that, okay? So there's our integer, right? Scalar overload, vector overload, and everybody's happy, okay? And we can kind of do that stuff there, okay? And I guess, notice, of course, we're adding the S, right? We're adding the S to both sides, right? To create our 2D vector, okay? So that is kind of the introduction to that. Not every class needs it, you know, and certainly not every class needs, you know, all of these things. But the comparison stuff is hugely important for sorting algorithms, right? And we can do, you know, these crazy things, compound assignment operators if we really want to. But part 2 later in the course, we're going to look at double increments, and most importantly, our vector friend implements faking arrays. So vectors don't support arrays. They are not arrays. They're actually a combination of exotic data structures in some cases, right? So they just pretend they are arrays. So when you say square bracket 1, it calls an overload for the operator square bracket, and then gives you back what it thinks you want, okay? So yes, question.
So the operator overload, they're like class specific, right? Or like if if you want to add different classes, that would be tricky. Could you do like an inheritance thing where you instead for
yeah.
a bunch of different
Yes, you could. Yeah, you could have a base class that implements it, and then your just children classes would have a different overload, and you could have a dynamic fallback. And we'll do that with chess. When we get to chess, we'll actually explore some of that stuff. That's called dynamic binding. It's definitely more, you know, high end stuff, which is cool. Yeah, you can do that. Yeah, definitely possible. But yeah, you can imagine that if you are trying to mix and match different types with some existing software that was written a really long time ago, you know, most of the rigor around this stuff enables us to get away with that. You know, it's just like that sorting analogy. But sometimes we run into stuff where we can't really get there from here, right? So that's kind of our topic for the day. I would like to spend just a little bit of time to talk about this risk thing. If anybody can hang with me just a little bit. This won't take long. We'll get out of here before 7, but you do have kind of a to-do as a team, so you can kind of, we'll just take a few minutes and see how we want to do this. But let's talk about it. So I do appreciate your feedback at this juncture because I am not a risk player at all, and I'm trying to catch up fast on this project. I kind of threw it down there at the very end. So what we'd like to do is slowly all learn how to play Risk. I'll bring in a game. Obviously, we're not going to sit around and play it together, but hopefully you can kind of read some of the stuff online. And in the course of writing the code, we will all slowly kind of internalize a lot of the rules. But the thing that I hope we all take away from this exercise is that, you know, we're going to have a lot of dependencies. Some of you are going to be writing a class that depends on a class that hasn't fully been written, or it's going to change and things are going to break. This happens out in the real world all the time as teams get bigger. And you always hear people saying, God, I could do it myself, and I wouldn't have to deal with all of this, right? But that only works up to a certain point. And so at some point, we got to learn how to manage the chaos. So that's what we're going to try to do. And in the beginning, we're not going to try to add too many data members because we haven't really learned how to kind of meld all of our code into one pile yet. We're going to learn that starting next week. But you can begin to think about what your class might need, okay? And there's something in C++ called a forward reference. So if you're using the name of a class in your class that you don't have the code for yet, you can use this thing called a forward reference. So let's say, take something out of the game. If you're writing the content class and someone else is writing the territory class, you can temporarily say, well, I'm going to tell the compiler that eventually there will be a territory class. But right down here, I'm going to create a vector of territories, and that, let's say, is the definition or part of the definition of a continent in Risk. Okay, so the compiler will be more or less happy so that it will compile your code for you into one of these little units that can then be glued on to all the other units. Okay, so that's a temporary get out of jail card that will let you maybe compile your code. It's called a forward reference, and you can look it up or play around with it. But don't worry if you don't even know what your class needs, right? All we want, quite honestly, for this juncture is for you to get to know, our team structure in Canvas, how it works, kind of meet a person or two, and one of you is going to be the leader on your team, and it will be your responsibility to do your initial submission. So our teams are going to have randomly assigned leaders. And this first one, unfortunately, for those of you who are leaders, you pretty much have to just submit the code, right? There's not much for anybody else to do at this point, unless you guys want to push your class forward a little bit. And you're welcome to do that for sure. But don't feel at this juncture, at this hour, on this day, that you got to go any further than just name of your class, curly braces, and a semicolon. And then I would like you at this juncture to have a main so that you know your class compiles, right? So I would like you to see if you can compile and create an instance of your class in the main, okay? So let me go through the details on this. So first off, we're going to use this feature of Canvas. I know it's a little clunky, but if you go to the people section and you look in the groups section, you'll see a group there. I think it's called the Risk Collaboration Group, okay? And I've randomly, just thrown people out there into different groups. The idea is, whether you want to or not, everybody will at some point be a leader. Everybody will be on a team with somebody else. We're going to kind of meet each other, at least in the mind, and maybe physically as we develop this board game. So click into the group, see where you are, and we'll pause here for a moment, just kind of go around the room and name off some names, and just so people just get a face with their group members. But really, all we want you to do this week, the minimum, you can do more, the minimum is submit a.cpp file that is named after your class. So if you're on the Group A game class, you're just going to submit a game.cpp file. That's all you're going to do. And it's going to have the game class and a main, and it's going to create an instance. And it's really, really very straightforward. You don't even have to have data members if you don't want to. Okay. So let's take a look at our first group. Sorry to out everybody here. So Eamon, you are the lucky guy. You end up being our leader for Group A. Okay, so Blossom and Kevin, are you guys here? Maybe just throw up a hand. Okay, Eamon, you're over in the corner. Maybe throw up a hand. Okay, so you guys, just at least you know each other. So this is a process I would like you guys to sort of organically solve. We'll give you some time here before you go, and we'll get to know each other a little bit. But we're going to use these groups kind of keep you together for a short while, but like out in the real world, people move on, right? They go to other companies, maybe they get sick. So we're going to remix the groups over time. The code is going to stay with the group, and you are going to move on to a different group. So when you write your code, think about what it feels like when you land in a new group with a whole bunch of code, right? So think about your comments the way you would like to be treated when you land in a new group. And we'll let you guys get kind of settled before we shuffle the groups, but that's kind of the process I would like to try to follow. So keep that in mind. Find your leader. Thank you, leaders, for the first time out. Make sure you know the name of your class. You might want to take a look at the game rules, but you don't have to worry about that too much tonight. And maybe some of you know each other in other groups and you know Risk. Hey, feel free to reach out to your fellow group members and go, hey, I see you guys are doing continents. I'm doing territories. Let's talk how we're going to do that. So we want to start to begin thinking that way, because that's really what happens out there in the real world. Okay. So this week, just a CPP file, simple class. Maybe a comment that says what your class does. You can take it right out of Canvas if you want. Create an instance, and it's a text file, so no links on this one. So I'm going to be your build master. I'm going to collect all of your files together, and we're probably going to build this off of GitHub. So we're going to find a way where everybody can go watch and see their code show up. And, some of us are going to break the build, right? Some of our code will break the build. That's okay. And then we'll just have to go back and fix it and figure out what's the answer to that problem. Okay. So we're going to stick with our text files for that. And we're going to kind of run this out over the course of the whole semester. Every 4 labs or so, we'll kind of sort of hit a new juncture point and we'll just figure it out, right? Because it's kind of a new process. So let me pause there. See if anybody has any recommendations, especially people who know Risk. Does anybody have any thoughts or questions, caveats at this point? Does anybody want to be the authoritative Risk, the Risk project manager who knows how to play Risk? I don't put anybody on the spot, but I know we got some Risk players, so one thing we'll do is try to figure out which flavor of Risk we want to build, because apparently there's several, and we may keep it simpler in the beginning and then grow outwards. So thoughts, comments? Okay, so let me just go real quick. Let me help you guys out a little bit, because otherwise I know we'll just be running around here. But let's do a show of hands. I'm going to go group by group. So group B, we have Lucas. Are you here today? Okay, Iago here, awesome. And then Eric is there, awesome. You guys are there. Group C, show of hands. We got Gabe, we got Philip here, we got Brett, cool, good. All right. Group D, territory class, Noah and Stefania, great. And then Sebastian, awesome. Okay, player class, we've got Esley, Pierre's here, Esley here, yep, okay, cool. Mason, all right, Mason's over there, great, okay. All right, combat class, Kai's here, and then Daniel, and then Arash. Yeah, great. There you are. Okay, didn't see you right in front of me. Okay, Wendy and Calvin is here. Awesome. And then Adrian. Oh, there you go, Adrian. Right. So okay. So you guys at least identify each other. Richie, you got the fun job. The dice. I always love doing dice. Ashley. Is Ashley here today? There's Ashley. Okay, very good. And then Ricky. Ricky all the way up in front. Awesome. Okay. So I'm gonna let you guys just say hello if you'd like. If you want to submit your class tonight, right here, right now, that's great. If you want to just get a head nod from people and then bug out and do it later, that's fine too. But does anybody have any questions before we just go organic on this? Okay. Yes.
How do you who's the leader?
So,
Because I'm in the people and person icon.
yeah, it's the little person. Yeah, if you open your group, you should see a little head above one person. Does that show up?
No.
You have to go to the people tab instead of the groups tab.
Oh yeah, that's where I was.
People, and then it's like everyone, and then there's a group section.
Yeah, sorry. Yeah, exactly. Yeah, sorry. It's one weird thing about this in Canvas is I can't see exactly what you guys see, but this is what I'm doing. I'm going to people, then I'm going to groups, and then I kind of see something like that. So yeah, it's weird.
Yeah, cameras just set up really weird. It's you can just go anywhere.
Yeah, I know. And it's the one thing that teachers can't see. So I can't actually see what you guys see on this.
Student view?
Not even in student view. It's really weird. It's like I found that out this summer. We were doing this in the NASA thing, and I was like, "What is going on?" So bear with me on that. If it gets really weird, we'll find a different system. But I am planning on shuffling the decks on this at some point. Okay. Final questions. Okay. Thanks, everybody. We'll see you guys on Tuesday. If you got questions, send me a link with your code, and we'll work through it all. Okay. Yeah. Let me go ahead and cancel our recording here real quick. So.
Yeah, he's not here.